Welcome guys, welcome guys. So this still video is we just trying to use a page to quickly review the quantum mechanics just for fun. Okay, so no pressure. Be sure to subscribe to my channel. Okay, so the quantum mechanics can be described as using a states uh, so state side, right? So state can be labeled by continuous or discrete, and then there's a basis n. So basically, people can write phi as a span of this basis as this one. So this is can be viewed as a coordinates, or basically the expansion. So basically, you can view there you have Hilbert space. Basically, it's a complex inner product space. So I think in quantum mechanics, always is the complex inner product space. Although in the mathematics that there are various kind of Hilbert space. So basically, I label it n. So n can be labeled. N can be a real number, continuous, or discrete, or others. But basically, just some complex vector space. Okay, and the observable is also observable is easy, right? Since you have a vector space, so observable should be just a linear map from vector space to vector space. But we always assume that A is Hermitian. Okay, so I should say Hermitian with respect to this complex Hilbert space, because Hilbert space means the complex inner product space. So there is a natural inner product. Okay, so basically you can define AB, define on inner product, define on the Hilbert space. So you can what actually A equals A dagger means that the x a y equals to a x y. Okay, and so this is just definition. And why this is real? Why this is Hermitian? Because if you see the linear algebra, or basically you see my other YouTube video, that all the eigenvalue of A will be real. So basically, if A equals to A dagger, then it can be real. Okay, and we can also expand A as the linear combination, like as the basis like this. So one can spend the phi and spend A, right? But basically, this is just write A into matrix. So this is also a standard thing. Okay, and one final result is basically if you solve the eigenvector of A, let's say n is the eigenvector of A, then basically given any state phi, when you observe phi, then phi will have different probabilities to becomes different eigenstates of the A. So if you try to measure, if you use A as observable, then the final you will get this is the probability that you observe phi will become the nth eigenstates of A. So this is the somehow like postulate of quantum mechanics. All those nobody cares. And the qubit block-sphere I already described it, so I think you can go back. You can see my other channels, but basically I just say only the important things that the pure states live on the boundary of block-sphere, and the mixed states live on the live inside of the block-sphere. So block-sphere is just some standard S2 sphere. So with the radius one. Okay, and another thing is the dynamics, right? So in the pure states that everyone knows about this Schrödinger equation. So basically, the quantum mechanics is very simple, right? There's a thing called Hamiltonian. So Hamiltonian is another Hermitian matrix, right? And its eigenvalue is just the energy. Okay, so you can view the standard quantum mechanics. Basically, you have Hilbert space H, and then you have Hamiltonian, which govern your system. And all the states, right? All the states in here, right, will just evolve as the Hamiltonian described. So this is the Schrodinger equation, and then everything of this is just quantum mechanics. I can write as h hat. So I write h hat just to make sure that everyone knows about h hat is the operator, or basically linear transformation from Hilbert space to Hilbert space. Okay, so this is the quantum mechanics. So in a usual standard particle that the standard 1D, then you will solve it, right? So everyone knows about this for the quantum mechanics 101. So for different well potential V, then you just solve in different side. Okay. So also another equation is that dA hat dt. This is a hat just a variable, right? So that you can view as the variable as a change thing. So this is the Heisenberg equation of motion of this A, right? Or Heisenberg picture. Okay. So qubit, nothing I want to say about qubit. Qubit is very easy. Okay. So finally, I just want to say about the density matrix. I just want to take a review. So suppose you have an ensemble. Basically, you have different phi A, right? And there's a probability distribution. So there's a regular sum of PA will be 1, and then this PA will greater or equal to 0. Right? If you have some probability distribution, and you can form a density matrix rho defined to be a sum of this PA, psi A, and A. Okay, so this is called a density matrix. Okay. And one result is a trace rho, which is just take this PA, so it will be 1. And easy to prove that the trace rho squared will be just PA squared A, right? But PA is greater or equal to 0 and less or equal to 1. So PA will just less than summation of PA, A. So this is just 1. So we got the trace rho squared is less or equal to 1. So if trace rho squared is 1, that means rho is pure. Otherwise, rho is mixed state. Okay. And also one can also check that rho is Hermitian. This is very easy, right? Okay. The reason is that if you can just check psi, right? Okay. So what I want to say. Okay, and also A, right? So this is if you want to make the A that you will get this PA, and right, just take. So this is A means that psi psi A, right? Orthogonality. If you plug this to A with this also okay. So maybe I should write psi B, and the sum of B, and final result you will get this PA and psi A psi A. So this is psi A psi A. Okay. Okay, so this is the density matrix. And the final I want to say is maybe is the dynamics of the density matrix. Probably this is the final one. I think it's important. Okay, so if one can roll is the PAA phi A, then one can check the derivative of time derivative, right? So it basically is this. So you get the derivative of phi A tilde phi dots, right? So if you let h if you plug out in your Schrodinger equation, then this is this. Okay, and your phi A dot is basically IH bar phi AH. You plug in, then you get this H. Maybe I just write out. So PA H phi A psi A minus you get the PA psi A, right? But the derivative on the other side, so you get H. I get sorry about this H. Okay. And if you check carefully, then this is just the right. This is just the H commutated commutated with the rho, right? Because rho is this. So H right, you see H econ so it should be plug this, right? So you see h plug just plug into the before this PA, so it's positive. So h row. Okay, and then one can write row as the standard. One can try to roll as the right into some basis. So then the derivative of this row hat will be ih bar, right? So we know h row, right? So there's nothing special. We just try to do this. Okay. Right, since we already plugged in everything, right? So this nm hat, this n dot will be the sandwich of this n and m. Okay, and then this is minus ih bar k nh. So you just plug k, right? So you plug it here. Minus n row k hm. Then you compute it minus ih bar summation k. So this is hnk row km minus row, right? This is nk hkm. So that's it. So this is the standard dynamics of the density matrix. So this is right. This is row k, row nk. This is hkm. Okay, so I think this is all the quantum mechanics, the important quantum mechanics, the key idea. Okay, now I will see you guys in the next video. Be sure to subscribe to my channel.